Okay, hello everyone, and thank you for joining this webinar. My name is Moore. I'm a lead architect at Port, and today we will be talking about enabling self-service actions for infrastructure and code using GitOps under the hood. Now, first of all, I want you to know this session will be recorded, so don't worry if some friend of you joined late maybe, or you missed a certain part, you want to repeat something. Don't worry about it at all. And we will record the session and then we will email it to you once this webinar is complete. Also, feel free to ask questions using the Q&A interface. I will do my best to answer your questions as we go along. But don't worry if I didn't get your question during the demo, I will for sure address it at the end. And I guess let's get started. So first of all, about me, my name is Moore Paz. I'm a lead architect here at Port. My background is software engineering and DevOps engineering. Over the past few months, I've hosted several webinars. For example, I hosted a webinar for the CNCF about introduction to developer experience. I also hosted a webinar for Port about mapping Kubernetes and Argo CD inside your developer portal. I love video games, I love bordering, and I really love burgers. Everyone around the office know that I know the best places around the area to eat a burger. If you ever stop by Tel Aviv, hit me up. I'll definitely have some recommendations for you. Now, what are we going to talk about today? So our session revolves around enabling self-service actions using infrastructure as code and GitOps. We're going to start by addressing how GitOps meets developers and how infrastructure as code meets developers and why that poses a certain problem. And then we will also talk about the solution, which is using Port's self-service actions. And then we're going to show a live coding demo where I show you how we solve these problems using Port. And then we'll have a short Q&A session. And that's it. So first of all, let's start with GitOps. GitOps can be pretty daunting for developers. It requires an understanding of DevOps practices, and it requires a high degree of trust because GitOps says whatever is committed into my Git repository and exists on my main branch, this is the actual architecture that I'm using. This is my Terraform file that its plan is actually applied. This is the configuration that my Argo CD actually uses. And it has a high sense of responsibility because a mistake in my GitOps configuration could lead to some incident or some error or some service not behaving the way it should. And because of that, it also requires a high degree of trust because every change needs to come with a pull request. That pull request needs to be reviewed. And we need to make sure that all of the correct personas have the permissions to open those pull requests and to perform these reviews. Because again, anything that goes inside our main branch could have some undesirable effects. Of course, GitOps makes our lives much more easier because it gives us that one source of truth for our code and for our configuration. But it's still something that needs to be handled properly and carefully. So this is some area where we believe developers are a little bit less comfortable dealing with. And we want to use developer portals and self-service as a way to lower the barrier for entry and make the task less intimidating. Now, infrastructure as code is another area that can be quite daunting for developers. Now, if we're talking about something such as Terraform or Pulumi, this usually comes with learning a new syntax. In the case of Pulumi, it means learning a new library inside a programming language that the developer might be comfortable with. If we're talking about Terraform, this basically means learning a completely new language and syntax. Of course, learning a new syntax is just one part of the issue, and the real hurdle is that because we're talking about infrastructure as code, every line that you write actually has some effect about the underlying infrastructure. And developers usually do not come from a strong infrastructure background. That is usually the job of the DevOps and the platform teams and the platform engineers. And that means that when a developer writes infrastructure as code, he needs to actually understand and dive deep into the infrastructure layer, which is something that usually he doesn't want to do, because he wants to get on with his daily tasks and he wants to get done with his actual coding and delivering features. And another level of risk there is that because the knowledge about infrastructure is not as high, it can also make it very easy to introduce new security vulnerabilities or bad practices, which again makes it harder for the developer to comfortably say, oh, sure, I'll just go ahead and write this Terraform file or this Terraform module and apply those changes and everything will be okay. He needs some layer of protection. He needs someone to go ahead and say, I'll give you the guardrails, I'll give you that golden path to make the changes that you want to perform. And that way he will be able to make the changes that he wants to make without actually being afraid of causing an incident or having some catastrophic effect because he wrote the wrong resource or used the wrong variable or forgot to mention something in his file. So these are the two main issues when talking about GitOps and infrastructure as code from a developer perspective. And now what we're going to do is we're going to introduce how ports and self-service actions that are provided by port can help you avoid those pitfalls and make it easier for your developers to actually make use of those self-service actions. And on the one hand, gain independence, but on the other hand, still do it in a safe manner that the platform team and the DevOps team decided that it's the best way to approach making changes in the infrastructure in an independent way. So the first step is actually identifying good ways to provide self-service operations. So if you have scalable use of infrastructure as code, you usually have something similar to what we see here, a certain Terraform module or Terraform resource definition that is pretty dynamic and can be configured with different variables according to the needs that you use. And what usually happens is that the developer will come to you and say, oh, I need a new document DB, I need a new S3 bucket, I need a new Lambda function, etc., etc. And when he says that to you, you go ahead and say, okay, sure, no problem. I have a Terraform module for that. Let me just throw in some new variables and we'll be done. You'll be on your way. But that process is pretty mundane and it's pretty repetitive. And there is really nothing that prevents the developer from getting those resources himself without having to ask the platform team or the platform engineer to do it for him. And this is why this is such a good use case for self-service operations, because the platform engineer can say, okay, I can expose this action to my developer simply by making the resource definition more parameterized and simply give the developer a way to tell me what parameters he needs. And I'll just inject those into the file and commit it. And then the infrastructure will be ready. But in a way that is safe, because the developer doesn't write the code himself, he just injects the variables and my script or my logic takes care of those variables and makes sure that they are inputted into the file in the correct manner, in the way that we decided in the organization that is the proper way to do it. So after we found that good first self-service action, that use case where we can expose some infrastructure as code functionality to our developers, the next step is to actually create that self-service experience. And how we do that is by creating that experience for the developers to consume via the UI and API, which is something I'm going to show you during the live demo. the end result is that the developer actually has a nice UI form where he sees clearly which inputs he needs to provide. And he can also see the entire process that happens in the background once he submits his request. So after we have that nice UI form, we're going to auto-generate that infrastructure as code file with the injected parameters and values that the developer gave us. Then we're gonna open a new pull request with those generated infrastructure as code files. And once that pull request is reviewed and approved, it's gonna get merged, and our CI process will go ahead and apply those changes. And the final step is going to be that we're going to update Port's developer portal with this new infrastructure, making sure that we always have the most up-to-date layout of our infrastructure inside the developer portal, and it also matches what is actually happening in our infrastructure. Now I can see that Costas has a question. He asks, who approves the pull request, a human or Port? So Port does not approve the pull request for you. And the job of approving the pull request is the job of the platform engineer or the DevOps engineer. It is also possible to expose a self-service action that approves the PR. But again, that will be something that would be invoked by the DevOps engineer or the platform engineer, and not something that is performed automatically by Port. And the idea is that Port sends you the payload of the self-service action and the self-service request, but it does not know for you what are the correct parameters and values. This is something that you need to be responsible for, and you need to say, okay, I'm seeing this request from my developer. I can see the effect it will have on the infrastructure, and I approve of this change. So I'll go ahead and merge this. But Port cannot do that for you because Port does not know about your infrastructure. It can map it based on data that you give it, but it cannot decide for you whether this change follows your practices or not. So this is the sort of shared responsibility between Port and you as a platform or a DevOps engineer, where we give you the payload and the request, and you go ahead and approve it. And I can see another follow-up question saying, if the whole point is to provide self-service for developers, shouldn't Port run the automated checks on the PR and auto merge it? So again, as I explained before, the idea is that Port can run those checks for you, or you can report the status of these checks from the PR, and it's also something that I'll show during the demo. But again, we cannot understand your entire infrastructure. So that is something that you need to go ahead and say, okay, I'm going to approve this change. It looks good to me. It follows my practices, so I can go along with it. So to give you a brief overview of what we're going to show in the demo, we're going to have a self-service action performed through the Port's UI. What that self-service action is going to do is it's going to trigger a webhook event. That webhook event will be sent to a Lambda function. That Lambda function will take those values that the developer asked to deploy in the infrastructure. It's going to generate new infrastructure as code files based on a preset template that knows how to receive those values that the developer gave us. It's going to open a PR in GitHub with those new files. That pull request will simulate or basically run Terraform plan over these new files. And once we go ahead and merge this PR into our main branch, a CI process, a GitHub workflow will run and actually apply those changes and actually create changes in our AWS infrastructure. And along this entire process, we will have a code that continues to reflect the action progress to Port. So basically, we will see that every self-service action has a run log, and that run log is completely up to your choice what data to fill in it. And this is another way that you can make life easier for the developer, because during certain actions, some very complex or very deep dive or low level processes are running, and you probably don't want to expose the entire process to the developer because it might confuse them and it might be a data overload or cause some additional cognitive load that the developer does not need. And the idea is here that you can only expose the actual logs that you think the developer will need to understand the context of what is happening, or maybe have some actionable information that he can use in case something goes wrong or in case he sees that something is stuck. And I can see a question from Anonymous saying, what happens if the apply fails after merging into main? So this is a common problem with managing infrastructure as code using GitOps. In this case, there isn't really anything special about using import. The best thing we can do in this instance is during the workflow that applies the changes, you can report that some failure occurred. What this will do is it will let the developer know that something went wrong, and he can alert the platform team or the DevOps team. Another thing that this might do is because Port has a way to listen to changes in the software catalog, you can also update a Port entity saying that the deployment failed, and that could automatically trigger a rollback. So that is one way that you can handle that failure of merging. And that is one way that Port helps you automating that process in case a failure occurs. But that is 100% a risk. Port just give you some more tools to handle it. And now, just before we start the demo, a few components from Port's internal developer platform that I'm going to talk about and show during this demo. So, of course, we're going to have the developer portal interface. We're going to use the UI to invoke a self-service action. And we're going to use the self-service layer, which introduces a self-service action and a payload that goes to a Lambda function that, in this case, I wrote, but can be any backend infrastructure that you choose to implement. And one more thing that we're going to show is we're going to show some role-based access control abilities that Port provides. For example, in this instance, the self-service action that I'm going to request is going to require some manual approval to make sure that not everyone can go ahead and just ask for a bunch of new infrastructure and maybe also create unnecessary resources, but also create resources that will have effects on our billing and the cost of our infrastructure, and basically creating those guardrails to make sure that only the actual resources that are needed are provisioned. Okay, so let's start with the demo. So I'm gonna start by showing a bit what I have made for you. So in here we have two blueprints, one for service and one for database. And the blueprint is a Port component allowing you to model how you want your software catalog to look. Basically, every blueprint is a completely customizable object, which you can choose its properties and its relations, those lines that you see going from the service blueprint to the database blueprint. And the idea is that every blueprint gives us a way to create entities that model certain objects in our infrastructure. So the service blueprint is supposed to represent our microservices in this instance. And our database blueprint is supposed to model actual database resources that we have in our infrastructure and that we can see in our software catalog. Now, in the service blueprint, I have created an action for adding a document DB. I'm gonna make this a bit bigger. Basically, the action is configured completely using JSON, and we should have a UI interface to hide that JSON and give you a more convenient experience for configuring new actions in the next couple of weeks. But the idea is that the JSON follows the JSON schema model and lets you configure all of the user inputs that you want your developers to type when they're requesting a new resource. And you can also put those guardrails in to make sure that they can't get out of certain parameters that you decided that they have to adhere to some limits in. For example, since we are configuring a new document DB, a document DB has a number of instances. And in this case, I decided that the number of instances that a developer can request can be anything between 1 and 5, but it can't be more than 5. So that is some limit that lets me make sure that the developer doesn't ask for too much infrastructure that he might not need. And that is just one example of how Port lets you protect both your infrastructure and your developers when asking for self-service infrastructure. Now, what I'm going to do is I'm going to go to the services page. And in here, I have a few services. And let's say that I want to add a new document DB to my mailer service. Now, assume that in this instance, I am actually the developer asking for a new document DB for a service that I manage. So I'm going to go ahead and say, okay, I need a new document DB. Let's use the add document DB action. And I'm just gonna type in some inputs. And let's say that I decided that I need 2 instances. And you can see I have a bunch of different parameters available for the instance class. But in this case, I think that T3 medium will be enough for me. So I'm going to click ahead on execute and launch that request. Now we can see that the action was initiated, and we can also see it here on the side panel, and you can see that the status is waiting for approval. And now again, being a developer using the self-service action, I can see the status and say, okay, I'm gonna wait till my my DevOps team or my platform team sees this request and approves it. By the way, the members of the platform team and the platform engineers will receive an email from Port saying, hey, there's a request waiting for your approval. But in this instance, since I am an admin in my organization, let's put on our platform engineer hat for a second and look at this request and say, okay, I see that you requested a new document B. I can see the parameters that you asked for. I'm gonna go ahead and approve this. Now, once I click approve, the action is actually launched. So in this case, like we said before, we have this webhook that is now triggered. Up until now, this sat in the developer portal. And now once it's approved, this payload is triggered. It triggers our Lambda function. And now the actual self-service action is running. I can see a few more questions. So while this is running, I'm gonna go ahead and I'm gonna explain this in a few seconds. I'm just gonna answer a question. So Kostis asks, will you show later the RBAC setting for deciding who can see what actions on which blueprint? Yes, I will show the permissions JSON and how we choose who sees which actions, who can invoke each action, and also how I configure that manual approval process that I've shown. So now that our action is running, we can see here the run log, and we can see all of these logs are logs that came partially from the Lambda function and partially from the pull request that we opened in GitHub. So you can see here that we can see that the action is started, and we can see the parameters that it's using, and we can see its progress live. And now we can see that we have a pull request created. And we can see the pull request here, the pull request URL here, and we can also see the pull request here in the metadata of the action run. And if I go ahead and open that pull request, what I want to show you is in the files changed, you will see that this exact template that I talked about showing the exact resources added to our Terraform file based on the parameters with the DevOps input. So you can see here that we are asking for a new document DB resource, and you can see the different variables that the developer asked for. And what this gives us is a way to continue to reuse the same code blocks for the different assets that developers ask for, and just continue changing or updating the parameters based on their requests. And something that this lets us do, which is something that I'm also going to show in a bit, is after this new infrastructure is deployed, the developer can go ahead and say, the configuration I asked for doesn't exactly fit me. I need to ask for some change. For example, I need to increase the instance count. So the developer will have the option to invoke a different self-service action, which actually asked for these changes. So we can see here the exact parameters that we input, for example, the instance count of 2 and the instance class. And if I go into the conversation part of the pull request, then I will also see the resulting plan. So this gives the platform team or the DevOps team a way to say, I want to understand the changes that the developer asked for, but I don't want to actually check out this branch and authenticate and select the correct workspace and provide the correct variable file to my Terraform CLI. I just want to review these changes, see if they work or not, and go ahead and approve it. And this gives the platform team exactly that functionality. So we can see here the exact infrastructure changes that will occur. And one extra important thing that we can see here is that we are going to use Port's own Terraform provider to actually create a new Port entity. And what's going to happen is that once this gets merged in and actually applied, this new database will also appear as an entity in our developer portal. So as you can see here, I already have a database that I use this action to provision. But once this gets merged, I will see here a new database. And if I go inside that database entity, then I can see its information, and I can even see a URL to this database in the AWS Cloud UI. And I will also be able to see which service actually uses that database. Now, if I'm going to go ahead and merge this will run for about 5 to 6 minutes and actually apply those changes. And that will take a while, and I don't want to just keep us waiting for something to apply. So I have made ahead of time an action that I already merged in, so we can see the exact log of the response after merging. So you can see here the action tells us continue this action by reviewing and merging the pull request. And now, after I merge that pull request in, I can see these logs that are coming from the workflow that runs on the main branch. And it says, okay, files formatted, Terraform initialized, the plan is validated and generated. And now we're setting up the Terraform apply. We're applying the new plan, and the plan was applied successfully. And if I want to go ahead and see the results of this plan, then I can again go ahead to GitHub and look at the workflow, and I can see this pull and apply action. Okay, this is specifically the one that adds the comment. So let's go in here. This is the pull and apply. This is what actually applied those changes in. And so you can see we have all of these add log lines, which continue to fill this log, which you see here, and it keeps the developer updated and makes sure that the developer knows what's happening. And here we have the actual apply. And the final thing that we have is reporting back to Port about what happened, so that the developer can know, okay, this action was successful, it finished just fine, and you can go ahead and see the results of the run here. And he can also see in the affected entities tab all of the entities that were actually generated or changed because of this run. And so, for example, in our instance, we asked to add a new document DB to the mailer service. But when I ran this originally, I used the encryption service, and I can see here the diff in the configuration of the encryption service, and I can see that it has a new database that was added to it. And this is exactly the database that I asked for. And so this shows us how we can use self-service actions to ask for brand new infrastructure. And like I said, I was going to show you how we can go ahead and edit some existing infrastructure. And the idea is that we do this in the exact same manner. Again, a self-service action that meets a Lambda function. So let's say that I have this document DB database, and I want to change its configuration a bit. Let's say that I want to keep all of those parameters the same as they were, but I want to increase the instance count to 4. So again, I can go ahead and put in my developer hat on, saying, okay, this is what I need. And so I'm gonna fill in those details. I'm gonna click execute. Again, my platform team will receive that request. So putting on our platform hat, let's go ahead and look at the request. It seems fine. Let's go ahead and approve this. And this will basically run a very similar process, which again goes ahead and creates those infrastructure as code template files and opens a new pull request. And in this instance, the pull request will again generate that comment, letting us see the plan ahead of time. And again, you can see that in this instance, because we have those parameterized files, I can just go ahead and enter and go inside my specific variable file and just edit the specific section that I care about. So this change is much smaller and it is much easier to digest. And again, in a few seconds, we should have the comment here showing us exactly the changes that are going to happen to our infrastructure in case this gets merged in. So this concludes the actual part of the demo that I wanted to show you. I'm gonna dive a bit more into some specific areas that people asked about. So one thing is that people wanted to see how the role-based access control is configured. So let's look at it from the service blueprint standpoint. I can just go ahead and look at the permissions view here. So this basically shows me the permissions configuration for the service blueprint. And if I go to the action section, I can see here the add document DB action. And I can see who has the execute permission for that action. So for example, I can go ahead and remove the member users, which will usually be your developers, and this will not let them invoke this action. And now an instance that you might want to do that in is if you maybe created an action specifically for the platform team, some specific change that the platform team usually does and is very automated, and they want to just invoke from port without having to manually go to their IDE or to their cloud interface, and they want to just invoke that from port. So a way to do that and actually giving self-service back to the platform team is to create these actions and just keep the permissions such that only the admins have permissions to use that action. But a configuration that is more likely for the add document DB example is maybe saying, okay, I specifically want member users to be able to run this action, but I want to make sure that this action needs to be approved when it's invoked. And I do that in the action definition by looking here and saying required approval true. And after I configure the required approval, another thing I can do is I can also specify a list of emails that will receive a notification when a request awaits their approval. And so that is the way that we use role-based access control to actually make sure that actions are invoked only by the personas that are supposed to and allowed to, and also that we have guardrails making sure that every specific and maybe dangerous or unique change gets looked before it's approved and before it manually runs. And by the way, our plan here is updated, so we can see that some new DocumentDB instances will be created. Remember that we asked for 4, and up until now, the number was 1. So now we will have 4 instances. You can see here the change from 1 to 4. Okay, so this was the part of the demo. And now is the time for some questions. If you have any, feel free to type them in the Q&A section. Okay, so I can see one question asking what can Port do with Ansible playbooks. So pretty similar to what I've shown here. In case a self-service request arrives and the developer needs to run a certain Ansible playbook or replay it, or maybe even the platform team wants to run that Ansible playbook, they can use a self-service action to actually trigger that Ansible playbook, maybe via a Lambda function, via a GitHub workflow, or maybe by listening to a Kafka topic, and once a message with the request to rerun that playbook, when it comes in, make that re-execution of the playbook. And that is a way that Port can integrate with Ansible playbooks. But it is also the standard way that Port integrates self-service actions in general. Now I can see another question for what other architectures does Port self-service actions support? So Port supports several methods of invoking self-service actions. And I'm gonna go inside the docs here to just show you briefly what are the different options. So what I've shown here is basically using the webhook actions interface, meaning that when a user asks or invokes a self-service action, a webhook is deployed and the payload is sent to a backend that you as the platform or the DevOps engineer you specified. And the idea is that this backend that you specified knows how to handle that payload and react to that action request. Another option that we have is using actual GitHub workflows. By installing Port's GitHub app, you can invoke an action, and that action can actually trigger a specific GitHub workflow in one of your repositories. So if you already have a pre-written CI process that you want to just let your developers invoke on their own, or maybe if you just want to save the trouble of having to open another tab and finding the correct repository and find the correct workflow, you can do it straight from Port, and it will just happen directly. Port will send that action will go to the GitHub app. The GitHub app will invoke that workflow, and you will see the status reported inside Port. We also have the option to trigger Azure pipelines using webhooks. And basically, the webhook will go to a webhook service interface inside Azure, and that service interface knows how to trigger a specific Azure pipeline. And we also support Kafka. So you as a Port customer can go ahead and say, I want to use Kafka for my self-service actions. In this instance, we will give you a dedicated, specific, secured Kafka topic. And every time an action is invoked, the payload will go inside that Kafka topic, and your backend can listen and pull that message from the topic, and again, handle it, parse it, and invoke that action based on what the developer or the platform team requested. And I can see another question from Costas. Apart from email notifications, can the DevOps team be notified with other means when a service action needs approval? So this is something that we are planning to implement very soon. Right now, it is only email, but we do plan to add some more options, such as Slack and Teams, and maybe certain other interfaces that platform teams would find useful to get notified in. And Costas asked, is there an audit log that shows when a self-service action was launched, who asked for it, and who approved it? So yes, Port comes with a complete audit log showing also all the changes in actions. So for example, if I go to the audit log here and look at the runs tab, then I can see all of the actions that ran previously. I can see their status. I can see which entity they were invoked on and which blueprint, if they were a simple create action, which does not have a specific entity it runs on. I can also see things such as the duration, and by going inside to that action, I can also see some additional information. For example, the user that requested and the user that approved it, the source that he requested it from, and all of the user inputs. So you have a complete audit log that always shows you what happens in the self-service section of your developer portal. What are your developers asking for? Who approves it? What are the most common actions? What actions may be failing and someone needs to take a look at? So all of that is enabled inside Port and built in right away. And Costas asks, can I define a specific time period or time window when a self-service action shouldn't be launched or approved? For example, I don't want any action to be approved during the weekend that touches production instances. So that is not an option that we offer just yet, but that is something that you can handle in your backend logic. And another thing that you can do, and something that actually we at Port use ourselves, is we use a service locking, meaning, for example, I can add to my service here a property called locked and give it a value of true or false. And then when someone asks for a self-service action and he wants to apply certain changes, I can go ahead and check which entity did he want to perform changes on. And in case that it's the weekend and I decide that I don't want any changes to be made, then I can specify it as locked. And when the workflow runs, it will check, is this service locked or not? And if it is, it will fail the action saying, this service is currently locked. Please wait until it is unlocked, or contact the platform team to make sure that this change can go through. So that is one way that you can control this. But it is something that we plan to add in the future and continue to improve our self-service actions engine and giving you even more control, making sure that you really give your developers that absolute golden path to use self-service and give them a high degree of independence on the one hand, without giving them the option to damage the infrastructure or stray from the practices of the organization. And I can see that we don't have any other questions. So thank you very much for joining this webinar. I hope you enjoyed it. If you have any questions, feel free to contact us. Also feel free to go inside demo.getport.io to get inspired and see where Port can go as a developer portal. And again, this recording, this session was recorded and will be sent to you. And so don't worry if you want to go over it again, or if you have some part that you missed. Thank you very much for joining us, and we'll see you next time.